So I asked you before I just came back here to scale down each of the panels with the center point or on the center point of the panel itself, which you've already found, and then measure the length of the list of how many panels you have that you've scaled. So it's really as simple as this. You've already got your area center point, and I did that differently before. You already have your area center point, and so the scaling part is really easy. You just go up to Transform and Affine, and you go to Scale. I think you all figured this part out, right? So the geometry is going to be the faces themselves, and then the center point, obviously, would be the centroids of each of the panels. That's how you get the scale factor for each of them. And it already comes preloaded with 0.5, so I gave you guys an easy one. Then I asked you to measure the length of that list. Now, in order to measure the length, you just go up to Set and List Length. And so by doing that, I can plug it in, and it measures, and this is kind of the tricky part. Now, you guys notice I'm throwing a lot of curveballs here. The tricky part is that every single one of these sets of the list, or individual lists, is reading as a value of 1. That's the funny part, because obviously this list is grafted, and so in order to measure the number of panels that I have to flatten it. So we unflattened, and now we're going back into flattening. Okay, so this needs to be flattened. Now, this is interesting now because we have to control which information is being flattened versus which information is staying grafted. So our next step is going to be moving the geometry along a particular vector. Okay, so it's not always going to be that vector. That's how I generated this definition. The geometry, you notice that the panels in the back, let me select it for you so you can see it. This one, that one. Yeah. So the panels that we scaled that are in the center, you can't really see it all that well up on screen, but that's right here. This panel is in the center of the, I guess, the original panel. But what we did was isolated 1 out of 4 vectors that are associated with that panel. And then we gave it a numerical value to shift it. So there are a couple of things we have to do here, and this is basically the most dynamic part of the definition so far. That's why I'm kind of walking you through it, so let's do it. But I'm going to do it working backwards. Okay? This is a perfect instance where working backwards is going to work for you. So I know that I want to move my geometry. I want to move the panels that I just created. I'm going to go to Transform, Euclidean, and Move. And this one right here says that it translates an object along a vector. And that's why I created the vectors in the first place. So I'll pull that in, and I'll take a look at what I need. So the geometry. The geometry I'm going to give it is going to be this scale right here. But I'm not going to plug it in yet because it's just going to move it upwards and confuse me for now. So I'll save that for later. But what I need to do is create a translation vector. And a translation vector has what? 2 things. What? No. Well, it could. It could have a base point, but... Huh? Direction's one of them. And what else? Magnitude, yes, thank you. So direction and magnitude. All of these things we're going to construct in 2 different ways using one that a tool that we have used many, many times so far in this class, and it's under vector and vector. It's called amplitude. Amplitude is going to allow us to pull a list of vectors, or one vector or many vectors, and then a list of other numbers that are not associated with any vectors we've currently generated. Okay, so for instance, this vector right here has direction and magnitude. So we don't want to use necessarily the raw vector. We want to override the magnitude with a new number. So simply put, let's see, yeah, 4 vectors. Yeah. So what I'm going to do here is kind of reconstruct this a little bit so that I can basically just get an isolated instance of these panels. Okay, so I realize that having every single one of the vectors mapped to every single one of the panels might be difficult to control. But if all of these panels are going to be in the same orientation, I can isolate one panel or 4 of the vectors, and I can well, actually, let's do it a different way. Actually, I'm gonna kind of go outside of what I prepared for you ahead of time, and I'm gonna do something a little different. So we have vectors. These vectors come in packs of 4. What we are going to do is measure how many panels there are, and then we're going to list item, but we're going to have a list that has variable numbers anywhere from 0 to 3 that many times based on the list length. Okay, so that's what we got this for. List length is 36. So let's take a look at that. 4 vectors per pack. Just so you can see it here. Get rid of this. Actually, I'll hold on to that. 4 vectors per pack. We need to list item to pull those vectors out. So I'm going to go to set and list item. Now the list is going to be the list of vectors. That's all well and good, except the vectors that I get are going to be, don't worry about that actually. The vectors that I get are going to be all of basically the first item, right? So index item 0. And they're all going to go in the same direction. So even though this is in the wrong location, they're all going in the same direction, right? That's not what I want. I want them to go in different directions for every single one. And so I need to change the index that it's pulling from. Right now the index is reading 0, and it's reading 0 in every single case. So I have to generate a list, 0 to 3, and repeat it as many times as I have lists, and jitter it so that it changes the number that it's grabbing every time. So let's pull this across, and I'm going to pull in the tools that I'm going to use. Okay, so I need repeat data. Actually, this needs to go back here. Sorry. Well, no. This goes over here. I need repeat data, and I need jitter, because that randomly shuffles that whole list. Now, the data that we're going to repeat, it's pretty simple. We're going to have 4 values, 0 to 4. And so you can do it a few ways. We can do it with a panel, or you could do it with a series of sliders. But this one is going to be 0, 1, 2, and 3, and make it multi-line, or make it an index list. Turn off multi-line data. So here's where the list length comes in. You plug the 0, 1, 2, and 3 into the data input. That's the pattern that's going to get repeated. And then you plug in your list length, and it's going to say, repeat this list until my new list reads 36 items long. So I'll plug that in. And now the panel is going to read 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay? So I'm going to pause here. Let me see how we're doing on time, actually. Yeah, this is probably a good place to stop. Okay, so I'm going to stop this video, and then I'm going to move on to, now that I'm going to jitter the list, and then assign that to isolate my list item vectors. Okay, so this is a new Boolean mask that's filtering out unwanted vectors. Any questions? Okay.